Hi, welcome to the ComSci 137 lecture. Sunny here. For this module, we will be discussing part 2 of the network layer. Let's start. Network Address Translation, or NAT, is a technology that can provide the mapping between the private and universal address, and at the same time support virtual private networks. It allows a site to use a set of private addresses for internal communication and a set of global internet addresses for communication with the rest of the world. All of the outgoing packets go through the NAT router, which replaces the source address in the packet with the global NAT address. All incoming packets also pass through the NAT router, which replaces the destination address in the packet with the appropriate private address. Translating the source address for an outgoing packet is straightforward. For incoming packets, the NAT router knows the destination address through the translation table. It can have many forms, such as using one IP address, using a pool of IP addresses, and using both IP addresses and port numbers. In its simplest form, using one IP address, a translation table has only two columns, the private address and the external address, which is the destination address of the packet. When the router translates the source address of the outgoing packet, it also makes note of the destination address where the packet is going. When the response comes back from the destination, the router uses the source address of the packet to find the private address of the packet. The use of only one global address by the NAT router allows only one private network host to access a given external host. To remove this restriction, the NAT router can use a pool of global addresses. For example, instead of using one global address, the NAT router can use 4 addresses. In this case, the 4 private network hosts can communicate with the same external host at the same time because each pair of addresses defines a separate connection. However, there are still some drawbacks. No more than 4 connections can be made to the same destination. No private network host can access 2 external server programs at the same time. Likewise, 2 private network hosts cannot access the same external server program at the same time. To allow a many-to-many relationship between private network hosts and external server programs, we need more information in the translation table. For example, suppose 2 hosts inside a private network with addresses 172.18.3.1 and 172.18.3.2 need to access the HTTP server on external host 25.8.3.2. If the translation table has 5 columns instead of 2, that includes the source and destination port addresses and the transport layer protocol, the ambiguity is eliminated. Note that when the response from HTTP comes back, the combination of source address and the destination port address defines the private network host which the response should be directed. Note also that for this translation to work, the ephemeral port addresses must be unique. The main reason for migration from IPv4 to IPv6 is the small size of the address space in IPv4. An IPv6 address is 128 bits or 16 bytes long, 4 times the address length in IPv4. The following shows two of the notations, binary and colon hexadecimal. Binary notation is used when the addresses are stored in the computer. The colon hexadecimal notation divides the addresses into 8 sections, each made of 4 hexadecimal digits separated by colons. Although an IPv6 address, even in hexadecimal format, is very long, many of the digits are zeros. In this case, we can abbreviate the address. The leading zeros of a section can be omitted. Using this form, 0074 can be written as 74. Further abbreviation, often called zero compression, can be applied to colon hex notation if there are consecutive sections consisting of zeros only. We can remove all the zeros and replace them with a double semicolon. Note that this type of abbreviation is allowed only once per address. If there is more than one run of 0 sections, only one of them can be compressed. Here are some of the IPv6 prefixes and the type. In IPv6, a destination address can belong to one of 3 categories: unicast, anycast, and multicast. A unicast address defines a single interface. The packet sent to a unicast address will be routed to the intended recipient. A multicast address defines a group of hosts. A packet sent to a multicast address must be delivered to each member of the group. An anycast address defines a group of computers that all share a single address. A packet with an anycast address is delivered to only one member of the group, the most reachable one. An anycast communication is used when there are several servers that can respond to an inquiry. The request is sent to the one that is the most reachable. The hardware and software generate only one copy of the request. The copy reaches only one of the servers. IPv6 does not designate a block for any casting. The addresses are assigned from the unicast block. Here are some of the reserved address. An unspecified address is used when a host does not know its own address and sends an inquiry to find its address. A loopback address is used by a host to test itself without going into the network. A compatible address is used when the computer using an IPv6 wants to send a message to another computer using IPv6, but the message needs to pass through a network that still operates in IPv4. A map address is used when a computer that has migrated to IPv6 wants to send a packet to a computer still using IPv4. IPv6 uses two large blocks for private addressing and one large block for multicasting. A sub-block in a unique local unicast block can be privately created and used by a site. It is used when an organization wants to use IPv6 protocol without being connected to the global internet. There are two types: the linked local address, which is used in an isolated subnet, or the site local address, which is used in an isolated site with several subnets. This ends Module 18. Thank you.